Very much, Dr. Davis, for your kind and enthusiastic and friendly introduction. Thank you all for being here today. Thanks for the invitation and the opportunity of speaking to this audience today. So the topic of today's talk is AI in medicine, and in the main slide you have some information about how to reach out to me via email, LinkedIn, or social media. Let's see if these things work as planned. I think now they do. Once again, my thanks to the West Virginia School of Osteopathic Medicine for hosting this talk and for Sigma Xi for making it possible. The take-home message for today's conversation is that AI will impact healthcare as well as every other aspect of our lives. AI alone will never be enough or take over. And the ultimate goal of using AI in healthcare should be to improve patients' and doctors' well-being. Let's take a look at how this is done and what are the challenges. First off, I have no conflicts of interest related to the material discussed in this talk. But as a disclaimer, I do have my biases and limitations, which are based on my background, my experience, and my ongoing work. As Schopenhauer famously said, every man takes the limits of his own field of vision for the limits of the world. And my field of vision is shaped by my training, engineering, computer, electrical engineering, my choice of career in academia, my roles as scientist and technologist. And on the personal side, I can consider myself an optimist. I believe that technology such as AI can and will improve people's lives through better healthcare in the context of this conversation. My work, as it's been kindly stated by Dr. Davis, is in what people call visual AI these days. So if something comes in the form of an image or a video or a medical image or an array or stack of images, and there's a need to teach a computer how to make some intelligent decision, whether it's detection, classification, segmentation, labeling, and so on, there's a chance I have worked with some of these over the course of the past 30-some years. Most of the titles of my books have keywords such as image processing, computer vision, video retrieval, video databases, and things like that. My work today involves partners not only at FAU, but also at the NIH, Stanford, some professional societies and companies and universities in the US and abroad. And my current focus is AI in radiology. So during the course of this presentation, I will give you some key ideas that I think will help delimit what is the topic that we are focusing on at any given point. So the first key idea to get us started is that each one of us sees AI differently. So if I show a picture like this with the words artificial intelligence and some futuristic looking graphics and ask you what is the first thing that comes to your mind, chances are each person in the audience will have a different answer. Maybe they will think about a scientific paper, a Hollywood movie, a company, a product, a controversy, or whatever it is that first comes to their mind, and that's fine. If you do a Google search and start with AI will and wait for Google to suggest what to do next, you will get the following suggestions. Of course, this varies from person to person, time to time. The first one will be AI Will Smith. That's Google's AI for you. The next ones will take the word will as it's intended, as in the future tense, and then you will see that most of the queries that people make on Google about AI have this negative tone, things such as taking over, killing us all, replacing humans, or something like that. So although the general perception based on this sample of Google auto-suggest phrases seems to be on the negative side, I will convince you that we should be more optimistic than that. So the second key idea is that AI is surprisingly hard to define. If you download a PDF of a short book called What is Artificial Intelligence from the O'Reilly website, you will see that despite the title of the book, there's a phrase that says defining artificial intelligence isn't just difficult, it's impossible, not the least because we don't really understand human intelligence. So even though the field of AI is more than a half a century old, it is still a matter of debate. What exactly do we mean by artificial intelligence? You can go to the dictionary and find definitions such as a branch of computer science dealing with the simulation of intelligent behavior in computers, or go to the encyclopedia and find the definition that uses words like digital computer or robot, or the ability to perform tasks commonly associated with intelligent beings. And that's all fine, and you can plug in your favorite definition here and we should be happy. But the issue of defining AI is in fact so complex that the leading textbook in the field, the one by Russell and Norvig, Artificial Intelligence, a Modern Approach, compiles tens of different definitions and puts them into 4 big groups. The ones that think of AI as the ability of thinking as a human would, or acting as a human would, or thinking rationally or acting rationally. And the book author's preference is for the acting rationally group of definitions or vision of AI. So that takes us to the next key idea. AI systems, for the sake of this conversation, are rational agents. What does that mean exactly? It basically means that these are combinations of software and hardware that are designed and programmed and trained and deployed to do the right thing. Since perfect rationality is not always possible, they often have to settle for limited rationality, which takes us to the famous value alignment problem. In other words, there's a need to ensure that the values or objectives that humans put into the machines, the algorithms, the AI solutions that they deploy, should align with those of the human. In other words, ultimately, we want agents that are provably beneficial to humans. And if the behavior of AI agents starts to turn a strange turn into what some people like to call awful AI, then we have to go back and see where the problem resides and who can do something about it and how to fix it. So in this world in which AI solutions are considered rational agents, they interact with an environment. So basically an agent captures relevant properties of the environment or percepts, typically using sensors, inputs that information into an intelligent algorithm, that's the white box with a question mark, and eventually makes decisions or predictions or otherwise solicits some actions that are imposed back upon the environment. The nice thing about this diagram is that it can be used for very simple tasks, such as playing the game of tic-tac-toe, where the problem is simple, it's static, players take turns, the rules are easy to learn and easy to model. So typically the algorithm is a decision tree of sorts, where some utility function is computed, say -1 if the computer loses, 0 if there's a tie, or +1 if the computer wins. And the number of moves is finite and allows for something close to an exhaustive solution mechanism to be built, something that you cannot do in chess or the game of Go, for instance. But the same simple diagram can be used for something incredibly more complex, such as self-driving vehicles, where the environment includes cars and pedestrians and traffic lights and lane marks and all these things. They are all moving, sometimes in rather unpredictable ways. The weather changes, there are distractions and everything else. The multitude of sensors is something to be taken into account. And as a result, not surprisingly, the algorithm becomes incredibly more complex. It has to reconcile input from multiple sensors, from GPS to laser scanners and cameras. It has to build and update a 3D model of the world. It has to plan the path, the safest possible path for the self-driving vehicle, and make decisions about throttle and steering, and eventually communicate those decisions back to the vehicle itself by braking or accelerating or turning on the blinker or whatever it is. The next key idea, and an important one to understand the state of affairs that we are in today, is that AI has had a bumpy history line with many promises and predictions that eventually were not fulfilled as initially intended. It is commonly said that the birth of AI can be mapped to a summer 1956 workshop at Dartmouth College, where some of the brightest names in mathematics and computer science got together and wrote a historical now document in which they write that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. So there was this feeling of optimism and the notion that since computers were becoming more powerful and more used in science, particularly in academic research, they could soon be used to emulate or simulate human intelligence. And what happened since then is basically a roller coaster ride. There was enthusiasm, promises were not fulfilled, and then there was the so-called first AI winter, and then new techniques and new hardware and new application areas came up, and the field experienced some resurgence in the late 80s, early 90s, to be followed by another winter, and now we are enjoying some very bright, flowery springtime in the field of AI. So the next key idea is that AI is indeed a very hot area again today. This can be due to a number of driving forces, including advances in computer hardware, from NVIDIA GPUs to cloud computing solutions to more powerful laptops, desktops, etc. Availability of huge volumes of data, which is a fundamentally important aspect of today's AI, since much of what we call AI is actually machine learning or deep learning. It's actually learning patterns from data, which require huge amounts of data. Better algorithms, which have been used to produce machine learning type of solutions to highly visible problems, from protein folding to the game of Go, to a few years before that, beating the best players in the game of Jeopardy and so on, and better sensors. And since I work with visual information, I like to show this slide where the gentleman on the left, Steven Sasson, is proudly holding the world's first digital camera. The year was 1976, and the camera had a resolution of 0.01 megapixels, weighed 4 pounds, give or take, and cost $10,000. Fast forward less than 40 years, and you have a digital camera sensor that is 1,000 times lighter, 1,000 times cheaper, and has 1,000 times more resolution, which, doing some silly math, you could claim by multiplying these three numbers that things got 1 billion times better in just a matter of 4 decades or so. The next key idea, which I have anticipated somehow, is that most of what we call AI today is deep learning. Deep learning is the name given to solutions that use neural networks, highly complex neural networks, sometimes with millions or even billions of parameters that need to be tweaked and fine-tuned. Deep learning solutions are the predominant way by which most of AI advancements happen today. Deep learning is technically a subset of machine learning, which follows the same paradigm of learning from data, and machine learning is a subset of the vast field of AI, which includes many other approaches that don't rely on the machine learning paradigm of learning from data. Instead, they use, say, rule-based mechanisms to teach what an AI agent should do. This diagram tries to clarify this point a little bit further. So in classical AI, say the expert systems of the 1980s, what we would do would be learn the rules from the experts, encode them in our computer program, and then once presented with data, they would elicit the answers and we could see if they were correct. In the machine learning era, we kind of flip this upside down. We give the system a lot of labeled data in the so-called supervised learning paradigm, which means data that comes with the answers. So pictures of cats labeled as cats, pictures of dogs labeled as dogs. We have the machine learning algorithm figure out by which rules a cat or a dog can be classified as such, and we see if it performs well on the so-called test data set. To give an example from dermatology, if I were building a skin lesion classification solution back in the 80s or 90s, I would probably interview dermatologists. I would learn maybe the mnemonic A, B, C, D, E, and the rules that they use to tell normal lesions from cancerous ones related to symmetry, size, color, and so on. And I would try to encode those things, the rules that I learned from the human expert, into my system. If you fast forward to today's AI, what I would do instead would be to collect thousands or tens of thousands or millions of images, if I could, that are labeled as, say, melanoma or non-melanoma, feed those images into a deep learning model, which typically, in the case of image classification, uses an architecture known as CNN, convolutional neural network. And after this model has learned how to tell malignant from benign skin lesions, I would deploy this model and test it with never before seen images. AI has had several highly visible successes in recent past, from Deep Blue beating Kasparov in '97 to IBM Watson beating the two best Jeopardy players in 2011, AlphaGo beating the world's top player in the game of Go in 2016, to AlphaZero, which is a successor of AlphaGo, doing the same for not only the game of Go, but also chess and shogi, the Japanese chess. And if you look at the timeline of these selected accomplishments, you can see that they started to intensify in more recent years. Not only that, the AlphaGo solution that beat Lee Sedol was eventually replaced by AlphaGo Zero, which beats AlphaGo 100 games to 0, and eventually generalized a little bit further to AlphaZero. So when I ask students what do they have in common, I normally expect two types of answers. One is that they are becoming more prominent in recent years. They are becoming deep learning based quite clearly in recent years. But very important for the sake of this conversation today, they are narrow AI solutions. They are solutions to very narrow problems, no matter how complex, such as the game of Go or the game of chess. And that takes us to the next key idea. When you read papers or news stories or talk to people about AI, it is a good idea to keep in mind that not all AI systems are created equal. And to do one better than that, I suggest you look at things from 5 different dimensions. The first one is a dimension of strength. How intelligent is this AI solution? Be aware that not every field of AI has an absolute measure of strength where 2 or more solutions can be compared against each other or against a benchmark. Incidentally, games such as chess or Go have such benchmarks, but most applications do not. The second dimension is the dimension of breadth. Does it solve a narrowly defined problem, or is it more general? 99.999% of the solutions out there are very narrow, and the Go, the holy grail of artificial general intelligence, is nowhere near us. The third one is training. How does it learn? Does it require a lot of data? How does it know if it's doing correctly or not? There's something called reinforcement learning. That's how some robots learn these days. If they make a right move, they get a reward. If they make the wrong move, they get a punishment in the form of mathematical adjustments to some functions. The fourth dimension is the dimension of capabilities. What kinds of problems are we asking it to solve? Even if you think you have narrowed it down, you say, oh, I'm interested in using AI in radiology. Okay, at which stage? You can use AI to better schedule your patients and make better use of your imaging equipment. You can use AI all the way at the other end to produce better reports. You can use AI to take the reconstructed images from an MRI or CT and make some intelligent analysis of those images. And even then, you may have to specify if what you want is to segment an image or to detect the presence of an abnormality or to classify among 2 or 3 possible types of lesions or tumors and so on. So we have to be very precise about what exactly are we asking the AI to solve. And finally, how autonomous those AI systems are. Are they supposed to work completely unsupervised, in other words, take over, or are they assistive technologies and presumably need an oversight from a human expert? In the question of narrow versus general AI, be aware that what we have today is mostly narrow AI, and a quote from Lukides and Lorica says that you can add narrow AIs ad infinitum, build a very tall tower, but you will never add up to a general intelligence. They don't work on a continuum. The progress we make along the way is not taking us to AGI, artificial general intelligence. We are just solving problems because it's become possible to solve those problems as we move the science and the technology further. Another key idea is that there's always an issue of terminology in this business of AI. Once something becomes a product, we don't call it AI anymore. So if Netflix recommends you movies, it's an AI, and you don't call it that, you call it the Netflix recommendation engine. Or if you get instructions of how to go from point A to point B from Google Maps, or if your Facebook feed is sorted and prioritized based on criteria from Facebook's algorithms, or you get targeted ads in your browsing and social media adventures, or you use Siri or Alexa or some type of agent to interact with you via speech. All of these things are examples of AI. At some point, they were research projects that could very well be hosted or housed in an AI division of a big company or university or research lab. But once they become a product or a feature, we call it a product or a feature. We don't think of it as AI. So in a sense, AI keeps becoming more and more prevalent in our lives. So there's no moment in time at which, boom, AI will take over. It's creeping in different products and services, even those that we don't call AI anymore. So there's a lot of things that AI can do, and it's impressive in its own way, but there's a lot it cannot. So in this slide, which I borrowed from Booz Allen Hamilton, on the left-hand side, I'll list some of the things that AI can do well, including performing simple, well-defined tasks, sometimes as well as or better than humans, finding and acting upon patterns in data, including patterns that may be invisible to humans, and getting better at performing certain tasks when the availability of data is generous, there's a lot of data, they are well organized and properly labeled. What AI cannot do well, on the right-hand side of the slide, it cannot perform any entire job better than a human. It cannot explain the mechanism by which it found patterns in the information or what they mean. That is the so-called black box problem or the explainability problem. It typically cannot understand the context that surrounds a given task. It cannot do well when there's not enough data or the data is of poor quality. And it cannot and is not even close to performing tasks that require creativity, empathy, or complex judgment, or for that matter, common sense. So there are many limitations indeed. But it is a true statement that AI will impact every area of human activity. If you ask Google how AI will impact and wait for the autocomplete, you'll see things such as jobs or HR or recruitment or the workplace, and for the sake of today's discussion, more importantly, how it will impact healthcare. So the context of today's discussion is primarily AI in healthcare, but I thought it was important to set the tone about AI in general so we avoid misconceptions being carried into the discussion and causing some damage. So here's a short movie from the World Economic Forum showing 7 ways AI is transforming healthcare. It has examples in dermatology, ophthalmology, helping coma victims and predicting when they will wake up, or diagnosing images from multiple modalities, or helping with drug development, or prediction of pandemic and recognition of depression using speech. And the reason I show you this short video with only 7 highlighted fields is to basically send the message that these 7 could very well be 70 or 700 or 7,000, and this wouldn't make for a good talk if all I did for the rest of this talk would be to give example after example after example of different ways by which AI is impacting healthcare. I would rather focus on this fundamental question: would you trust AI to look after your health? And we'll go back to that question later in the talk. So keep that in mind as we go forward. Would you trust AI to look after your health? So first, if you think, okay, I don't, but I don't need to because it's just a buzzword, it's just a fad, it will go away, I'm sorry, but I have to disagree. I strongly believe that AI in healthcare is here to stay. It's not only because of what you see in the news, but also in scholarly publications. Think about the Nature Medicine 25th anniversary edition, which was entirely dedicated to medicine in the digital age, for example. And by almost every measure, number of publications, patents, VC deals, startups, and so on, things are growing. Of course, there was a little bit of a dip thanks to COVID-19, including startup activity. There's a little bit of saturation in some sub-areas, but there's still a vast space for innovation. This is an ode for our standards. February 2017 is considered old, ancient perhaps, but still useful, diagram that shows at that time a map of 106 startups that were hot in healthcare with AI. The ones on the top right are in the space that I'm more interested in, which is medical imaging and diagnostics, and maybe half of them are dead by now, who knows, and 10 others have appeared since then that are now hot. I wouldn't be able to tell this without going to the proper sources. But if you look at other branches of this tree, you see areas such as virtual assistants or wearables or emergency room and surgery and so on. But then if you zoom into any sub-area, say eye health, then you'll see a large number of companies, sometimes specialized in glaucoma or cataracts, or doing something that is more related to telemedicine and telerefraction and so on. If you look at a specific use of AI in ophthalmology, which is the ability to diagnose diabetic retinopathy, researchers from Google and in partnership with other research teams have produced algorithms that show performance comparable to that of ophthalmologists. We can go back to this discussion of how tricky it is to compare the performance of AI models with human experts later in the Q&A perhaps. But at any rate, eventually this type of development led to one of the first AI solutions approved by the FDA, so-called IDX-DR, from folks from Iowa State University. And this is now a commercial product that detects diabetic retinopathy and does not require a clinician to interpret the results. The next key idea is that AI in healthcare has multiple facets and dimensions. So as much as I like the space of automated image diagnosis, which is here in this potential annual value chart by Harvard Business Review and Accenture, as much as I like to promote activities in this area and do research and team up and publish, there are many other areas out there, some of which are likely to be much more lucrative. Robot-assisted surgery have a market estimated to be in the $40 billion range by 2026. And if you look at robot-assisted surgery, very high-tech, automated image diagnosis, very scientifically challenging. But if you look in between, there are things that are much more trivial to the casual observer or less scientifically minded, such as optimization of administrative workflow or handling fraud detection as two of the examples. In that briefly mentioned special issue of Nature Medicine, January 2019, one of the papers writes about a call for deep learning healthcare. So deep learning has become this pervasive buzzword that even medical practitioners use to refer to a healthcare system of the future in which all of our information will be stored digitally, including past clinical decisions and outcomes, as well as our personal and clinical data, demographics, the world's literature, and so on. AI systems will help with computer-aided diagnosis and treatment selection, will synthesize results for recommendation to the human expert, which will then discuss with other human experts on what is best for a given patient, reach a clinical decision, add the data and the outcomes to the knowledge base, and hopefully continue to improve over time. Another way to show the breadth of applications of AI in healthcare is this diagram from Dr. Eric Topol in a paper for the same issue of Nature Medicine that shows AI being used from before the birth for embryo selection for IVF, all the way to hours or days before death in palliative care, prediction of whether a patient has another 24 hours in the hospital, for instance. And in between the two extremes of our lives, there are a multitude of options to add AI to multiple components and tasks in the healthcare ecosystem. However, being successful in such ecosystem is not as trivial as it may seem. In fact, I like to borrow an idea from Dr. Keith Dreyer and say that AI in healthcare requires a new equation. This slide and the next are from Dr. Dreyer. In this one, he basically says the recipe for success in AI typically consists of four main components: a lot of data, powerful computers, robust algorithms, and massive investments. If you have those four and you know what you're doing with them, you are likely to succeed in AI in general. However, this simple equation is just part of the longer list of items that you have to be successful with to make a dent in healthcare AI. In addition to having a good AI product, you have to have domain expertise. You have to understand the healthcare environment. You have to understand the vision of AI healthcare for the institution or hospital that you're partnering with. You have to make sure that what worked in the lab continues to work well after doing clinical translation studies, integrating into the workflow of, say, radiologists, getting FDA clearance, commercializing, maintaining the product, updating the product, ensuring that it doesn't suffer, say, from distribution drift, working well in the first hospital that has been deployed, not so well in the second one, and getting worse over time, for instance. So there's much more to success in healthcare AI than the basic recipe for success in AI by itself. The next key idea, and a simple one to agree with, is that AI in healthcare is a team sport. Much like medicine itself, it's a combination of humans and machines. So just as when you meet with your primary care physician, you implicitly benefit from the discussions that this medical professional has had with surgeons and colleagues and nurses and radiologists to define on a course of action for what's best for your health. Similarly, AI can be helping with some of these tasks. So Philips Medical Systems, for instance, call these adaptive intelligence. Some other people call it augmented intelligence or assistive intelligence. So they repurpose the A in AI to mean something different than artificial. And Dr. Topol puts it very well in his Nature Medicine 2019 paper when he writes that human health is too precious. Relegating it to machines, except for routine matters with minimal risk, seems especially far-fetched. I like to think of AI in medicine as an orchestra where eventually a few musicians, maybe entire sections, will be gradually replaced by AI or augmented by AI, and yet the role of the conductor, the role of the human musicians that sit in the same section will remain virtually unchanged. They will have to, of course, learn more about AI to better select products, interact with vendors, get the best out of the products that they choose for purchase and whatnot. They will still be responsible, say in the orchestra analogy, for keeping the sound of the orchestra, keeping musicians not only playing the right note at the right moment in time, but creating the entire feeling that the orchestra is greater than the sum of its parts. And if it turns out indeed that the orchestra will eventually have more AI players than it had a few years before, it should happen in a way that is meaningful, gradual, and doesn't hurt the overall experience of the audience. So, does AI hold promises for better healthcare? It does. Can we trust promises related to AI? Maybe, maybe not. Look at what happened with AI in general and the AI winters that I spoke about earlier. So the most optimistic folks in this space talk about AI in medicine bringing better healthcare. They use keywords such as preventative, personalized, quantitative, patient-centered, holistic, you name it, all of which are fine and dandy, but again, the proof is in the pudding. If you don't show how exactly you get there, these become empty promises. There are some encouraging signs from people who are early adopters of AI solutions. This MIT Technology Review report with GE Healthcare showed, this came out a year and a few months ago, that medical professionals using AI report that AI has decreased the time spent doing clerical work by 61%, increase the time they have with patients by 45%, and given them more time to perform surgery by 46%. These are encouraging numbers. No medical doctor that I have ever met says that their favorite thing in the world is to type things up or fill out forms or reports or update records. If AI can help with that, that's great. And if the time savings in this clerical task can be reverted back to giving more time with patients or surgery or some tasks for which folks, such many of you in the audience, have been highly trained to do, everyone is better off as a result. So there are indeed many challenges ahead. Some are on the technological side, how to ensure that even the most promising and shiny research projects that work so well in research labs with sometimes publicly available data sets or Kaggle challenges and so on, that they actually go well when they undergo clinical translation, that the solutions can be integrated with the workflow and so on. There are challenges on the legal and ethical side, issues of fairness, biases, privacy, liability, and this could take many, many more hours of discussion. There is a desire to keep the human in the loop. No one in their right mind wants to give complete power to an AI algorithm to make life or death decisions on behalf of a medical doctor. But the question is, how exactly do you keep human in the loop? How much AI can help, how much it can take care of some perhaps easier tasks or tedious or cursory or clerical tasks, and yet have some degree of oversight and a good friendly interaction, say, with good interfaces and user experience and so on. And of course, there's the very important component of explainability and trust, which brings us back to our question from a few minutes ago. Would you trust AI to look after your health? I've written about that recently in the Journal of the American College of Radiology, and the issue of trust is fascinating and quite complex, so I'll try to be brief here. Basically, to place confidence in something or to rely on something, to trust something, can be broken down into trusting people, trusting processes, trusting places. And it's a fascinating field of study that takes into account aspects from cognitive psychology, behavior economics, human factors, and it's still not fully understood or modeled or implemented, and it's hard to test and to quantify. So trust in AI particularly typically breaks down into trusting the data upon which the model was built, trusting the model, trusting the workflow around it, the programming practices, the test, validation, etc., or the people who built the AI, or all of the above. So these are questions that are being discussed by the AI in healthcare community as we speak. In fact, they are being discussed by the AI community at large, and there's a lot coming up in that direction in the next few years. So trust is highly dependent on context, which is something that state-of-the-art AI cannot capture or understand for many tasks. So in my provocative opinion paper for the Journal of American College of Radiology, I claim that despite the excitement with this subfield of AI called XAI, or explainable AI, I claim with my co-author, Dr. Felipe Kitamura, who is a neuroradiologist with deep understanding of the computer science aspects of the solutions, he and I claim that explainability might not be sufficient to promote trust in AI. In fact, it might not even be necessary. Let me show you what I mean. Explainability these days typically mean adding post hoc explanations to the decisions made by an opaque black box deep learning solution. So here's a screenshot from work by folks from Stanford, which built a deep learning model that takes an X-ray image in, and using a pre-trained or carefully trained 121 layers of neurons, convolutional neural network, produces a result saying if the patient has or does not have pneumonia, and not only does that, but gives a degree of confidence in their decision and adds a post hoc explanation in the form of a heat map, basically saying the hot areas are the ones the algorithm looked at more carefully and informed the most in the final decision. Of course, if you had labels as to what was the diagnosis underneath each of those, and you were trained in inspecting chest X-rays, this would help you say, okay, I understand why it tells me this, and I see that it's looking at the right areas within the chest X-ray. So it's not that the model is interpretable, but it has been enhanced with this type of post hoc explanation capabilities. However, even those who have created models that have interpretability and explainability built in, such as Dr. Nigam Shah from Stanford, they claim that trust is earned over time. So this is an interesting finding. Dr. Nigam Shah, who is the co-author of Improving Palliative Care with Deep Learning, a solution that can predict if a patient has another 24 hours or not, or you should call the family, and has ways to say why it thinks so and how it arrived at that decision. Dr. Shah says that when it comes the time to do his duties as a medical doctor, none of those is good enough. The reason or the aspect of the system that he uses is to inspire trust is actually how well the model has worked in the past 2 years. So even though interpretability is possible and so is explainability, they are, in the words of Dr. Shah, poor surrogates for trust. He decides to make that call to the family or not based on the quality of the predictions over time, something that post hoc explanations or even interpretable models cannot replace. So to conclude, before I start with the Q&A, the future of AI in healthcare is, in my optimistic opinion, extremely bright. It's tough to make predictions about the future, says Yogi Berra, especially about the future. So I'll leave the predictions to those who specialize in those types of things. But if you read reports such as the CB Insights report on healthcare for 5 or 15 years from now, you'll see that there are certain trends from proactive, passive monitoring of your health. They refer to patents being filed by Apple or Google or Amazon for things such as turning your phone into a monitoring device, or using optical sensors in your bathroom to monitor blood flow, or doing wireless heart rate detection, and so on. More devices being ingestible or implanted in our bodies and having a greater degree of intelligence associated with them. Eventually, as Dr. Topol mentions in his paper at Nature Medicine, from which I got this figure, we may evolve to something that he likes to call the virtual medical coach model. In other words, with a rich and incredibly large amount of data that goes from genomics to physical activity, sleep logs, medication, lab results, family history, all medical history, all the world's medical literature, presumably we might come to a point where all this can be digested by very large, very complex, very rich deep learning AI models. And as a result, we'll get some personalized virtual health guidance that is best for each individual case. That's a fascinating scenario to work towards. It's still far in the future, but there are many examples of work pointing in that direction. The patient-doctor relationship may change from a more reactive approach today to a more proactive approach in the near future. That's also from CB Insights. And hopefully, in spite of all these changes, the goal of improved access and improved quality of healthcare for all will be at the forefront of all these efforts. So to conclude, I like to quote my friend and mentor Alan Kay, who said that the best way to predict the future is to invent it, and invite all of us to build and invent a better future with AI together. Thank you. I'll be happy to take your questions now.
Thank you very much. Do we have questions? Feel free to raise your hand. I can call on you, or you can chat your questions. We look at the chat feature and see if we have any questions come in. I guess to get things started, sir, I do have a sort of off-the-cuff question that I've always thought personally. I've never expressed this opinion to really anyone else, but I think in the future that there will be sort of a kiosk, and you will type in your symptoms and it will give you the most likely diagnosis. Do you actually think that is not as far-fetched as one might have thought 10 or 15 years ago? Do you think that's the way AI will be moving? You know, I know that there's been a lot of marketability with the Watson model and in terms of identifying, you know, a person's health risk or health behaviors or most likely diagnosis. But so what do you think about that in terms of inputting one's symptoms or risk factors and age into an algorithm and giving you the most likely diagnosis? Do you think that's actually probably really close in the future and not as futuristic as one might have thought 10 years ago?
I will start by answering in a provocative way by saying we already have that. It's called Google.
Yeah, no.
Most of my medical colleagues claim that one of the hardest parts of each appointment these days is to spend however many minutes are needed to dismiss the findings that the patient brings from Google searches, which often don't end up in reputable places such as Mayo Clinic or WebMD, but instead in Crazy Bob's advice for health or something like that. So I think this model is not quite the one we're going to go moving forward, because it is hampered by a number of things. And I'm building the answer as we go. This is a question that I haven't been asked in quite some time. First, there's the issue of communication. The patient is supposed to be able to express in words their symptoms, even if we talk about check boxes and guided questionnaires and sliders and so on. There's a lot of margin for error. Patients not quite knowing how they should call the symptoms that they are facing and whatnot. There's this nebulous past of people doing that with the non-intelligent, not even trustworthy websites. So I think many folks who have a good solution would try to steer away from being even compared to a Google search or something like that. Third, there will be so much in terms of devices that we will have or carry. Think an Apple Watch with lots of capabilities that keep growing and achieving higher ratings of FDA clearance as new generations come up, that we will probably volunteer certain reputable apps and health providers to have access to, and therefore bypass the communication issue. If my watch knows that I'm on the brink of a heart attack because it's monitoring my health actively, I don't have to think twice about whether I'm feeling a certain type of pain or whether it's called this or that. It will trigger the proper action. So I see a future in which much of this will be done in a more proactive way. I don't know if this type of kiosk type of solution will become a prevalent model, but having said that, everything is in a state of flux. Think about telemedicine in general and how much has been changed and relaxed in terms of regulations since COVID-19 came into the picture. So making predictions is extremely hard, but my gut feeling is that this market for questionnaire-like, kiosk-like consultations may not be where the future is headed, but it may be a supplementary set of tools for the future healthcare ecosystem. It remains to be seen.
Do we have any other questions? I know Dr. Davis is listening to us, but he had some technological difficulties and he's not able to communicate with us. So are there any last minute questions before we conclude today's talk? We got a chat question that came in. We have a question. What do you think is the impact of the emphasis on privacy in medicine has on AI progress in medicine, i.e. data privacy?
Right, excellent question, thank you. The issues of privacy are central to AI in medicine, and not only you have to comply with HIPAA regulations, you have to anonymize or de-identify any type of patient information that might be present, say in a chest x-ray or something. But interestingly enough, in addition to all that, hospitals, say, or health systems that own a lot of data don't want to share that data so easily. So in addition to the problem of data privacy, there's the issue of data sharing at large. And this has led to some interesting technological developments. For instance, distributed learning, one flavor of which is called federated learning, in which, roughly speaking, you train a model in hospital A, and once you think it's doing well enough, you ship the model, but not the data, to hospital B, where it gets additionally trained with data from that hospital, and you ship it around, and you go around however many stops you have in this federated learning network. And as a result, ideally, the model keeps getting better, no data gets transferred, and issues such as distribution drift, working well in a hospital and doing horribly in the next, become almost automatically resolved by virtue of having successive improvements using multiple data sets from multiple sites. So it's one of those cases in which the privacy aspect, even the data ownership aspect, which is beyond privacy, become the triggers of technological innovation.
We have several questions came into the chat. The next one is, what would be the best way for individuals early in their medical education to become better familiar with AI and how to use it?
Wonderful. I love this question because I'm working with colleagues from the Schmidt College of Medicine here at Florida Atlantic University exactly on that. My medical school colleagues and I are working on surveys and integrative review papers and things like that to bring AI to the curriculum, the undergraduate medical education curriculum. There have been papers in the literature. Most of the papers are in the spirit of there's a need, but very few go further and answer the question, yes, but how? My colleagues and I are boldly moving in that direction. We want to arrive in maybe 1 year from today to something that says, teach these contents with this emphasis. The content should be taught in connection with this course or this material. It should be taught by people with this background. The educational goals should be those. The tools should be those. So we are getting to the point of answering the yes, but how question. The yes, there's a need, with all due respect, is widely accepted. Every study about student or faculty perception of need of AI in medical education shows high response rates saying we need that. The general consensus in the field of radiology, for instance, is that AI will not replace radiologists, but radiologists who don't know AI may be replaced with radiologists that do. This could be extrapolated to medical profession in general, and there's an urgent need to adapt and modernize the curricula to be able to accompany these changes. So keep an eye on my Twitter feed or something, because as these results become public and papers get published and announcements for surveys go out, you'll see what we are up to. And if you have concrete ideas or want to collaborate, particularly those of you in the faculty who may be willing to help us filling out the surveys and participating in this effort, please drop me an email and we'll take it from there. I think you're muted.
I was going to say it's 2 minutes after the hour, so we are running low on time, but we do have 2 other questions that came in, sir. As future doctors, what advice do you have regarding keeping up with AI and the advancement in AI?
Couple of pieces of advice. One is very self-serving. I have an AI bootcamp next week. If you Google AI bootcamp, FAU, Marquez or something, you'll probably find more information. Try to get some general knowledge of the field, especially if it involves some hands-on, sometimes with a little bit of coding, sometimes with no coding required. The more you know about how AI works, the more you have your hands on actual examples or tools or demos, the more you will be able to tell hype from reality. The second piece of advice related to that is to keep on reading, read reputable sources. Read Dr. Topol's Deep Medicine book if you haven't yet. That's mandatory. It's a phenomenal book. I've read it once and I am on my way to starting it again. Keep an eye on specific developments. Talk to your faculty in the School of Medicine. Keep things going. Congregate with colleagues who feel the need for AI in the curriculum, and promote talks, promote awareness, found AI in healthcare interest group type of thing. I am the advisor for our College of Medicine AI in healthcare interest group. We occasionally bring panelists and professors and speakers from all over the world to speak. In other words, start to create a culture on one side, keep reading and being informed, follow reputable sources on Twitter and so on, and if possible, break the barrier into the programming, the computer part of things. Try to learn more about how it actually works. You'll be surprised at how much your knowledge of the limitations of AI becomes more clear once you see how these models work under the hood.
The last question that came in from James is, do you know which institutions are at the forefront of research into AI? And are they more private companies or more government oriented?
Okay, I think my general piece of advice is follow the big names. I mean, every major company has very robust AI divisions these days, the likes of Google, Facebook, Amazon, Netflix, Apple, etc. And so do the ones in specific spaces. So if you are in radiology, big names such as GE or Siemens or AGFA will have very robust AI divisions. Not only that, they will have their own research infrastructure with startups and incubators and whatnot, and follow prominent universities, top journals, and you'll have plenty to be inspired by.
Dr. Davis, are you with us? Did you manage to get connected? Assuming not, I'd like to thank everyone for attending today's 2021 Spring Seminar Series, the Sigma Xi guest lecture. And we would like to thank you very much, sir, for your talk on AI. I think we all learned a lot, and we probably see AI in our medical field more than we know. So I think it'll give us an appreciation for things to look for in the future. So with all the accolades coming in, thank you very much, sir, for your presentation. This session will be shared with everyone if you were not able to attend. And so we'd like to thank all of you once again, and we apologize that Dr. Davis wasn't able to give us our concluding remarks, but I will try to do my best, Dr. Davis impersonation. And so thank all of you for joining us today. And thank you very much, sir, for your fine presentation. And we'll be in touch with you. Thank you, sir.
Thank you so much. Thank you all. Stay well. Take care.